Hello and welcome. Let's first talk what we are going to cover today. In this session, we are diving into something that every DevOps team care about: monitoring Kubernetes cluster with Prometheus. I've broken the tutorial into simple steps so we can follow along easily and actually see the value as we go. We'll start by spinning up Kubernetes cluster. This is our playground. Without this, none of the magic happens. Next, we will bring in Prometheus and Grafana so we can start collecting and visualizing metrics. Then we will install Node Exporter to grab node level data from each and every node of the cluster. And we will also talk why it is important. After that, we will deploy Kube-State-Metrics to monitor the health and state of Kubernetes objects such as pods, deployments, and more. Then we will hook in a C advisor so we can see container level states. This helps us understand what our apps are really doing inside the cluster. We'll also set up service discovery so that Prometheus automatically finds what it needs to monitor and we get rid of the manual work. Finally, we will conclude by monitoring the control plane, and we will also learn how to monitor extremely critical components of the control plane. So here we will talk about several use cases. When it comes to a control plane, it might be possible you do not set up a control plane at all, or maybe using Kubernetes as a service and somebody else is managing your control plane, or maybe you are providing a service to somebody. We will discuss about it in very details and several use cases as well. We'll also go over to recommended dashboard for each and every use cases we will discuss today, and I believe we are going to cover, I think, 9 to 10 use cases about the Kubernetes monitoring. So it's not a beginner level tutorial. There are so many things, so many stuff we are gonna do in this today's session, and by the end of this session you will have a complete monitoring stack that gives you insight across every layer of your Kubernetes setup. So before we go ahead, I would like to acknowledge and thank each and every one of you for your kind support and love which you are providing. That's really incredible, amazing, and truly rewarding as well as motivation to us. So thanks very much for that. And these are our social media handles. We would love to stay in touch with you. So without further delay, let's go ahead and get our hands dirty. Before we switch to the terminal, one quick thing: all the YAML files I'll be using are available on this GitHub repository. Okay, and everything will be uploaded in this one, Prometheus Kubernetes monitoring. Okay, feel free to clone the repository or fork the repository from over here, or follow along if you wish to. All right, so let's jump to the terminal to rock and roll. Okay, so first let's create Kubernetes cluster. So I'm using minikube start dash profile and DSOC3. So minikube will create one cluster with the name of DSOC3. I mean, the node name will be this, or of course the profile will be. So it will take some time. Meanwhile, if you want to know and want to deep dive into Kubernetes, day 7 is our in the playlist you can find, where we have spent very good amount of time, approximately 10 hours or 9 or something, just to understand the Kubernetes concept. So feel free if you want to refresh or if you want to deep dive, and everything is timestamped, so you could learn over there. So let's go ahead and check, are we connected? kubectl cluster info. All right, so I'm connected with the cluster. So let's first deploy the Prometheus itself. So for that, let me go to the directory Kubernetes, and inside that we have a Prometheus YAML file. Okay, so I have three things over here. I have a config file, okay, and Prometheus deployment file and Prometheus service file. So let me open them over here: 1 config, 2 deployment, and 3 service. So we are going to deploy them in this order. Okay, so in this, first we will create a config map. Okay, so again, the day 7, where we have learned each and every object. Okay, so this is the object, this is the config map is the object. We are using the object Kubernetes object deployment, and another is the service. Okay, so here we have 3 YAML files. In this we have a config map. We are going to create config map with the name of Prometheus config. Okay, namespace monitoring, and here is the data part. This would be our name of the Prometheus file. Okay, so since beginning we deployed right in VM, in containerized. So now we have very solid understanding, and we are really ready to take the setup to the next level, or I would say the more complex level. And here we know, okay, global script config is this one, job name is Prometheus, and localhost 9090, right? So this is about the configuration file, and we know the config map is the object which provide this facility. I mean, when we have any of the configuration, so we use config map. So that's how we create config map over here. And this one is deployment. Right here again the same thing, we are going to deploy it in monitoring, and replica is one. It's okay, selector mesh label app, this template for the pod, right? And here are the container specification. I'm using this one, Linux ARM, because based on the my VM, right? And of course it's a argument. We are providing argument as a config file where it can find the config file. So this config file will be etc prometheus.yaml, and port will be 9090. And let me do one thing, instead of showing you over here, quit all. Yeah, let's learn over here. Yeah, that's great. I think this will be more friendlier version of those files, right? Instead of going and doing the things on the over there. So okay, so this is the deployment file, right? Here we have a replica one, okay, and these are the selector, okay, this one, and here is the template for our pods, and here we also have the labels, right? These are the, it's a specification of the container. And here you could see the port. We know 9090 is port of the Prometheus, and we are mounting a volume inside the container, and we have a volume name is config volume, right? And why do we need volume? So we are mounting config map as a volume. So we saw right in day 7 there are several ways, but volume is I personally prefer one of the best way. So I'm doing this, but feel free if you have other, or if you want to explore other use cases as well. Okay, so volume we have mounted. Then we talk about the configuration file, right? And here is the configuration, and then we have a service. Okay, and the service name Prometheus service monitoring, and we are using node port. Okay, if you have a cluster with ingress controller already deployed, so you don't need to, okay, or however you want, there are several ways of service, right? So go and refer day 7 part 2 timestamp. You will find timestamp for the service itself. Go ahead and learn about that. And here we have a port 9090, target port, node port. So if you don't define node port, right, so it will be automatically provided by the Kubernetes, but I want to use my own node port. That's why I have provided over here. Then we have a selector, right? And we already talk about selectors are really important. If you mess up with the selector and the labels, you're not gonna get anything. Okay, so I think it's enough on this one. We learn, I mean, I explain you. If you have any questions, ask me. I'll give you, or I'll provide more information. So let's deploy first thing, kubectl. Let's check cluster info. Okay, so I'm connected with the cluster. Let me clear the screen first. Okay, let's start with creating first object, kubectl apply -f, then because it use the file. So first we will create a, okay, namespace monitoring. Okay, my bad. We must create a namespace, no big deal. Create namespace, and let me copy this over here. And okay, instead of that, let's do one thing. Kubectl apply dash and one prometheus.yaml kubectl apply -f. Okay, so Here it has created config map, deployment is done, service is there. Okay, let's clear the screen and hopefully everything will be up. Get all namespace monitoring. All right, so pod is running. Okay, service is created, and this one is means everything is fine. Our deployment is working, right? Next step, let's access the Prometheus. To access the Prometheus, what we can do the of course port forwarding. So let's do it here. So I would say ssh-p. It's my server. Okay, and before that we need one thing, minikube IP. Come on. Okay, sorry. If you are not using any profile, then this command will work for you. Profile is resoc3. Okay, so this is the IP. Okay, let me copy it and clear this screen. Kube-City will get svc equals to Prometheus. Prometheus. Come on. Okay, if I need to type this monitor. Okay, so at the moment we have only one service, right? We could also do like Prometheus -l and the namespace. So when you have multiple, right? So you can simply provide the label, and that's why I said labels are very, very important. So this is our Prometheus service, which is listening on this one. So this, I mean, on this host or on this machine, okay, node port service is there, and this is the node port. So we will use this, okay, and I would like to access this 9090, and let's put the IP address. What's the IP address? Okay, here we go. We have IP. Okay, so I'm putting IP over here, and IP of this machine. Okay, sorry, where it is listening. And after that, I have to provide my login credential. DevOps. I believe so far you have been watching me to do this thing several times, so I believe now you are very familiar with what I'm doing. Okay, so SSH-p, and this is the port L, and then we are opening SSH tunnel 9090. We will be accessing Grafana. No, sorry, not Grafana, the Prometheus 9090. This one, this op3 127. Okay, so let me provide the password, and here we go. Localhost 9090. All right, so our Prometheus is accessible. Let's check the sanity thing. Okay, so it is able to scrap itself, and that's why we are able to see up. All right, and query and all these things we already talked, but still, if you want to check it, you could also check it like this, up, graph, and there are so many other things as well you could do it. Okay, so in the series, okay, our Prometheus, it's fine. Now what we need to deploy the Grafana. That is our step number 2. Okay, so files are already over here, so I think that would be better to visualization. Right, so Grafana deployment. So for this is the same, right? API version, we have a kind, so we are deploying from Grafana also as a deployment. Then of course in metadata, namespace monitoring, replica is 1, right? Then we have a selector mesh label. Okay, so this must be matched with the this one. Okay, this. Okay, so that's why I put the same, so there would be no confusion at all. Okay, so this based on this mesh selector, pod will be selected, then template, and of course container, and container is like this. Second, think I have missed something over here. Let me check. Let's zoom to the screen. CD to Grafana. Okay, let's check. Okay, so I have different files. So Grafana, What do we have over here? Okay, so I am showing it's a different one, and we want something different. Okay, let me do one thing. Move this file Grafana deployment to home. Okay, so we are good to volume deployment. We want this one to volume deployment, and here we go. Okay, so we don't have this thing. Let me copy it and port. Yep, correct. All right, so let's come back again. I'm sorry about that. Sometimes happen things, but we got it on the right time. Okay, so container, again the same thing, right? One replica, labels, template, containers, and the name of the container is Grafana. We are using this image, okay, and container port is 3000, volume mounts, and here is the thing. Here I'm using persistent volume claim. Okay, so persistent volume, this volume is different here what we saw. Okay, then so you can also use volume or persistent volume to create or keep the data. I didn't do that, but it's recommended to do. And same, just copy paste from here and change this and play around it. It's fine. Okay, so all the data of the Grafana will be in this persistent volume claim. So again, what is this? We talk in day 7 part 2. Go ahead and find the timestamp persistent volume and learn about this if you want to. Okay, so just in short, persistent volume, it means we want to save the data and we need some place. So Kubernetes provide different ways, and we are using one of the ways, persistent volume claim, and the claim name is this one. Then we have a service, okay, and the Grafana service namespace is this one. This is also node port, right? And for that I'm using 330 300 3. These are the port, right, by default. So Grafana listens on, and the selectors are required, right? So service can connect with the ports. Okay, so we have one deployment. Okay, it's the same one. Okay, fine. So I think I copied 2 times. My bad, but just ignore this one, or we don't need it. Let me remove it. Anyways, we are not gonna deploy it, but just to sake of simplicity, we won't be confused. Okay, so persistent volume, this is how we create. Okay, it's again a object, persistent volume claim, and a PVC monitoring and access mode, right? And storage size is 5 GB. I could have shown you without this one, but I would like to show you how or what are the things you could monitor. So when we go ahead and progress in the hands-on part, right, you can also monitor the volumes, persistent volume, all the objects. So we will see that later. Okay, so this is the thing. Okay, let me switch back to the terminal and let's go ahead and deploy first kubectl live-1 Grafana persistent volume claim. Okay, and to check that, we have a command kubectl get pvc persistent volume claim in the namespace monitoring. Okay, and here we go. Let me show you on this screen. So if you see, wait, here we have a name Grafana pvc, and important thing over here, when you create persistent volume claim, it status must show as a bound. Okay, if it is not, then there are some problem. Okay, you have to fix the troubleshooting. I mean, you have to do the troubleshooting and fix the issue. Okay, so we have seen one scenario, right? Again in day 7 part 2. Anyways, so our pvc has created. Next, deploy the deployment. That's fine. And kubectl get pods, okay, in namespace monitoring. Okay, let me type it. Oh, okay, I'm sorry, this way. And kubectl get all. Okay, and this time we want to add equals to Grafana in namespace monitoring. That's fine. All right. So we have over here pod, which is running. Okay. And why don't we have service? Okay. So service does not have the label. That's why. So instead we could do one thing, clear the screen, option, remove, get all in the monitoring. Okay. So that's how it happens, right? So for the Grafana, pod is running over here. We have service Prometheus. Okay, we do not have the service for the Grafana. Well, let's see what happened with that. Okay, so where is the service? Kube-State-Metrics, I think we did not apply it. See Grafana.service. Okay, so now let me check. Okay, still the service does not have label, but we can check it like this. Kube-State-Metrics get SEC in space monitoring. All right, so Grafana service is here, right? So let's go ahead and do like this. Let me copy paste this again, right? So we know the IP is this one, but okay, 3000. Let's access is on 3000, and on our cluster it has exposed this port, so we need, there is another way as well if you want to. So you can simply do the use a kube proxy and you can access on the direct port. Okay, all right, so we don't have to come again. So now we have both as a service, and we go over here, localhost 3000, default password, admin. I'm fine with that. I'm not gonna change now. Okay, so we have seen this Grafana screen, right? Welcome screen several times in several different parts when we deploy it. Here the interesting not thing, the connection. Okay, where actually many people get confused. Okay, and yes, confused I would say, and especially when you are doing the things or setting up this first time. Okay, this is the problem. What's the problem? For the connection, right? So data source, we know how we can add a data source. There is no big deal over here as well. So we are gonna add time series. There are several as well. We have a Prometheus. So we do this, and here we have to provide Prometheus server URL. So here, how would you provide the URL? So there are multiple ways, and that's why we created the service. Okay, and here if you see serial, I think the same one, get SVC, right? So we can access the Prometheus, right? Or this bot can access the Prometheus using the service name. In this setup, we have the service, so we are taking the advantage of this. So how we can do HTTP colon and first copy the service name. Okay, and yeah, here we go, Prometheus dash service, and which is in the this namespace. Okay, kubectl, I mean, if you want you can check like this. Okay, and we have monitoring namespace. So first you have to provide, let me make a zoom it. Okay, so first HTTP, and here you have to provide the service name first part, then separate by the dot, then give the namespace name. Okay, and after that it's a svc. Okay, cluster dot local and colon 9090. How I know the 9090? I could see over here. Okay, it's a port of the pod. You could see here the port, right? Now once you are done Prometheus, so any service you could access. So these are the local resolution. Okay, that's why we have one service DNS, right, that we talk about in day 7 part 1 when we talk about the architecture components of the Kubernetes, right? Let me copy this. Let me show you once again what I have done. This Prometheus dash service name is the same what I have over here. If your service name is different, make sure you copy the proper service name over here. Okay, and Then you have to give a namespace. If your system or if your deployment, if you're deploying in default namespace, you don't have to provide the namespace name. My namespace is monitoring, and this part remains the same. Okay, svc.cluster.local, but yes, we have to provide port. And after that, come over here, that we have done several times in day 8. So successful queried the Prometheus API. All right, go back, and after that we need to, or we want to see some dashboard. Okay, so let me import very quickly just to verify. 3662. Okay, dashboard not found, but I have typed 3662. I said 2, but I typed 3. That's great. Prometheus overview. This is just for checking. All right, so we have, okay, up 1 hour, 100%, right? Everything. So some of the things we will see later, right? So we have a lot of information, right? And as time goes, we will talk about this more. I found this very nice, and if you are interested to, maybe if you are as a DevOps, you are setting up and your monitoring team wants to see whether that tool is working fine or not, right? So you can import this, and after that you could share this dashboard with your team. Okay, similarly you can do it for pretty much everything, right? So all right, this is our dashboard, and our setup is working properly and everything seems good. Okay, now let's go ahead and see the next thing, right? The node exporter. So for that, of course, we will go over here, and for that I have another folder, free, clear the screen. So we know we need node exporter, and we also know what it does. It gives us host level metrics. Okay, but here is one catch. Let's see what is catch. So one is a node exporter deployment file. Open, let's open this. Okay, so here it's a little bit different. So what little bit different? Because it has to provide a or scrap or yeah, collect a lot of metrics or a lot of information from the host, right, or node in terms of Kubernetes, right? In Kubernetes world, we say host, sorry, node. So same thing, we have created one service account, right? It's a name, monitoring, of course, it's the namespace, and here interesting thing, it's a daemon set, right? What it does, yeah. So again, day 7 for more information, right? But daemon set, because we want information about each and every node of the cluster, right? And daemon set is one of the object, Kubernetes object, which facilitates this service, okay, or this kind of facility by which we can deploy and then be free. Okay, so Kubernetes will make sure this node exporter, okay, as we add or remove the node, right? When we add a node, automatically new pod will be spin up over there. When we take out any of the node from the cluster, then automatically the pod will be evicted from the that node, right? So, and without any problem. So it will be automatically adjusted and managed by the Kubernetes. That's why we are using the daemon set. And rest is the same, right? We know already on, I mean, the functionality wise, these are different, right? With the deployment as a stateful set, okay, and the daemon set. So in this case, our requirement is to use daemon set. That's what we are using. And the YAML file pretty much looks like the deployment, right? Then selector, node exporter, then we have again the template, right? And then here in specification, right, here we use a service account, and this service account which we have created about the node exporter. Then we give it a host ID true, network is true, okay, because we need information. Containers, and the name of the container is node exporter, and image I'm using this one, Linux ARM based, okay, of course, because based on the my system. Okay, so check uname dash m, what is your Linux, not Linux, what is what architecture of your system, okay, the processor, and based on that use the respective image. Then we have ports 9100, host port is like this, and here we are giving a name to a port, okay. And why we are giving a name to a port, right? We should be seeing numeric value over here. So hold your thought on that. We'll talk this. It's one of the very interesting thing. That's why I put it over here. Volume mounts, again, these are the volumes we are mounting. Mount path read only true. Volumes, again, the root, host path, like this. Okay, so this is about the files, and don't worry, I will be sharing all these files are available, okay, in GitHub repository. Feel free to take it out, use it even for your, if you're setting up this monitoring in your company, okay. So feel free to do that, but you cannot sell this content to anybody, so check the licensing thing. But anyways, this for you guys, you could use it. And then we have a service, okay. So remember, service account and service both are different things, okay. That's we already talked before, so don't be confusing that. This is the service to access the pod, okay. Service account, where simple, it's a non-human account, that's it. You are providing some particular things, so that by using that service account, right, node exporter can perform its job. Then we, of course, this is the name, okay, and the spec is and this selector port, again the name matrix 9100 9100, okay. So this is the entire stack of the node exporter, and let's go ahead and deploy it. kubectl apply-f apply one dash node exporter.eml. So three things has been created, or three objects more accurately, right? That's the correct term in Kubernetes world, right? Three objects. So one is service account, another one is daemon set, and third one is service, right? Next, what we have to do. So let's go ahead and check our Prometheus targets, okay? Because we have deployed, and here, okay, guys, here the thing is, if we wait entire life, we will not able to see anything over here. Reason, yes, it's the same. Let me show you why. So we have to update the Prometheus configuration file. As you know, right, we talked in part 4, part 3, part 2, no, yeah, 3, 4, 5, yeah, this one is 6, everything, right? So we have to update the configuration. So I have already updated the configuration over here, okay, and I would like to show you something, but let's understand first the configuration. So we know this is the same configuration or same config file. I have just given a name. If you are following along, okay, and if you don't want to have multiple config file, so you have to just copy these many lines and put in there, okay. And what exactly I have done over here, so I'm taking advantage of Kubernetes service discovery configuration, okay. I have provided a role endpoints. Here are some of the reliable configs, okay. Let's do one thing. Let me, yeah, comment this out. So there is a thing, one point I would like to discuss over here, that's why I'm commenting this out. So here we are saying source level, okay, Kubernetes service name, and I told you in part 5, right, when we saw this container monitoring, how I find this. So simple copy, and if you go in query, right, if you type like this name, sorry, oh sorry, not here, my bad, over here, right. So we do not have much over here. Let me first configure it, and then we'll come back over here. So I will show you from where you can get it, okay. But these are the levels, okay, you find it. So there are two levels, one is service name, right, another one is namespace. So we have provided two levels over here. Action is keep and regex. What we want to do, we are saying okay, the here the service name. Okay, we want node exporter, so this is the service name, node exporter, and the namespace. So it's more control on what we want to monitor. Okay, if your use case is something different, okay, or if you simply say okay, I don't want to do this, so I will show you more ways later on, right? What you could do over here, or for example, if you let's hold the thought first, otherwise there will be lots of confusion will be created, and I don't want to make any confusion. Okay, so Kubernetes service discovery, this one, okay, we have to put job name is node exporter, okay, and label, these things are important. And in this we have provided two levels, service name, and here we say okay, this is this service, and in this namespace. Okay, so let's save it because we have comment out some of the things, and kubectl apply -f to Prometheus config.yml. Okay, so it's a configured, right? Let's see the configuration is applied or not. No. Okay, so we know in this case what we have to do. Okay, we can do two things over here. So let me first show you. So we know until and unless our pod does not or want to restart, then this configuration will not be applied. So simple way, kubectl, which is not recommended, but anyways I will show you another way soon. And Prometheus, okay, and monitoring. So what we are doing, we are deleting pod, okay, and kubectl that node nodes pods, okay, and label is this one. And so you could see 13 seconds ago, and if we go over here, all right, so here we could see, right, our configuration is applied, level configuration, endpoints, all these things. And now we can check the target health. Okay, one empty. So here we saw something show empty pulls Prometheus. Okay, so empty is the node exporter. So Prometheus is able to, Prometheus has created a job and but it does not have any information. It does not find anything. It shows okay, no active targets in this scrap pool. So what's wrong? Okay, pod is running. So for that, there is, let's check the logs. Let me clear the screen. Qt logs -app, not app, sorry, from Prometheus. One second. Okay, kubectl. Okay, why not app? Copy this one. Provide name, monitoring, and yeah. Okay, so what it says here, do we have error? Okay, we have error, this one. Okay, let's copy it and understand what it wants us to say. File, no, it will go here somewhere, word wrapping. Okay, that's fine. So it says okay, this level error. Okay, this is not a thing for us. Unhandled error, unhandled fail list. Okay, fail to watch, endpoints, fail to list. Okay, endpoint is forbidden, user system service account monitoring default cannot list resources endpoint in API group at the cluster scope. Okay, so here it says forbidden. Okay, endpoint is forbidden. It means there is a problem with the, of course, so we need to resolve this. So here basically this error, it says the service account, right, which is being used, it is not able to do anything because it does not have access in the cluster. right? So we can do one thing. Let me clear this up. Okay, so for that we have another YAML file which is rollback access control, okay, which is again the access concept in Kubernetes. Okay, so here what we are doing, API version is this one, which we are using kind cluster role, right? So we have to create a cluster role and cluster role binding, two things. Okay, and the name is Prometheus, and this is the API group. And we are saying, okay, API group, this which resources we want, or we are providing access to: nodes, proxy, services, endpoints, pods, everything. And what it could do, can get, it can list, it can watch. Okay, then API group extension, ingress, and yeah, metrics, everything, right? So these are the different APIs. If you want to learn more about APIs, go ahead and learn from the official documentation, and you can also see kubectl API versions. Okay, that command will also give you the details, and API resources. There are two command, right? Those who are preparing for CKD exam, they know these are the important commands. So let's back to the topic. So this is about cluster role. Now we need a cluster role binding. Okay, so again, RBAC, this one is our API version. Okay, it's kind, metadata, of course, name, the group is this one, and kind is cluster role, right? This is the role reference. Okay, because we have to bind, and to which we are binding. Okay, so we have to provide reference, and this is the cluster role, and the name is Prometheus. Here it's a role reference, right? So we are connecting the cluster role name Prometheus. Okay, and then we have subjects, right, where we have kind service account, and the name is default, and namespace is monitoring. What does it mean? So in this, we are granting a role to the default service account in the monitoring namespace. Okay, so if you want, if you do not have the use case, okay, to, let's say, ingress, I just put it like if you have some ingress controller, it's good for that, or some matrix or something is not there, feel free to remove if you don't want to. Okay, well, let me exit. I did not make any changes over here. Let me apply this. Then 3. Okay, sorry, my bad. Let's fix this. All right, so yes, cluster role is created and role binding is also done, right? Okay, so now let's check the Prometheus endpoints. Let's refresh this. All good. So now we are able to see the node exporter, right? So before, the error was, we have fixed the error. Okay, the issue because it does not have the proper permissions, we created cluster role as access and the role binding, so it could access all the details. Now we are able to see this, and let's, now node exporter is deployed. So let's import the favorite. So we know how we can do this. Click on new, import, and here we have to give a dashboard ID and 1860, right, which is yes, this one we have been using since starting, right? Import, and we are done, right? We have lots of information, right? Let's give it like this so we could see the more over here. Let's just last 5 minutes. Okay, so once we install node exporter, then Prometheus is able to scrap. Okay, and in this dashboard we could see that very easily, and we have checked this several times. If you want to learn more about this, what is happening, just go ahead and check file system, use etc, host, resolve. There are so many, and it's one of the best I found. The dashboard ID, that's what we are using. Okay, so far what we have done, let's quickly check it. kubectl get all, or I will check it over here. kubectl get all in the namespace monitoring. So far we have deployed Prometheus, right? Or yeah, and then we have deployed Grafana, right? After that we have deployed node exporter, right? So all and node exporter as a daemon set, right? So that's what we have done so far. So first we created a cluster, okay, and after that we wanted to know the metrics related to cluster itself, okay. And why do you need to know? So for example, you are setting up a cluster, maybe you are working for one of any of the client, and you don't want to lose anything, okay. You want to see everything is working fine, okay. And this has actually happened, and that's why I'm deploying everything in a sequence, right? First we deploy, I mean, we created cluster, then we wanted to know, okay, we wanted to make sure all our nodes are healthy, right? That's why, and to make sure the nodes, we need something that can provide us a node related information, and that which is provided by the node exporter, and we could simply see by this dashboard, right? Everything is okay, everything is green, no problem. Memories, of course it's a 2 GB, but you could see the used is 841 MB, right? And then we are good. We could also see over here, okay, everything is there. So this is what we have done. Now once cluster is there, after that you want to deploy some workload, right? You will create objects like maybe the deployment or daemon set or stateful set, or want to deploy some of the workload, right? So once you have workload, right, then we want to also monitor the workload. So to monitor a workload, next is our setup, okay, and how we can monitor all the workload. And in short, I would say how we can monitor the Kubernetes objects which we are creating, okay. And so far, like, we have created this many, right? Services, pods, deployment, daemon set, or if I do something like this, kubectl get all, and HA, right, we have a lot of resources, okay. So so far we are sure, we make sure, I mean, we have make sure, okay, our cluster is healthy, its nodes are healthy, everything is working fine. Now we want to level up, okay, or we want to go to the next level where we want all the workload, right, should be fine, okay. So for example, so far whatever we have done, it's for, let's say, the Kubernetes admin team, right? They want to make sure every of their cluster, because it's their job, right? So cluster is working fine. So that's what we have done. And next it comes to the Kubernetes application developers, right? They want to make sure whatever they have deployed, it should be healthy, okay. And for that we have the Kube-State-Metrics, okay. And fourth, it's our thing our thing. So here we also have file, okay, deployment file. Let's understand this. So not for first, okay, I have given a name to the file in each and every directory. By that sequence I'm going to explain, and I will deploy. So feel free, it won't hurt if you deploy in different way, okay. So here what I have done, Kube-State-Metrics. So again the same thing, it is going to getting details, right? So we need service account like node exporter, right? Then we have here the service account, Kube-State-Metrics, and namespace is monitoring, and this is the name of the service account. Again the same thing, okay, RBAC cluster role, and the name is Kube-State-Metrics, right? This is the role, and the role, what we have done, again the same thing, API group, resources, we want it to provide the information, pods, nodes, namespace, service, endpoints, persistent volume, right? So it can list, it can watch, apps, deployment, stateful set, daemon set, replica set, list, watch, batch, right? Everything, whatever you want this to, or whatever information you want from the cluster, or your Kubernetes application development team wants to watch, I mean watch, it means monitor, okay, or the information they're interested in, accordingly tweak this file, okay. Then of course cluster role binding, Kube-State-Metrics, RBAC, cluster role, service account, right, and Kube-State-Metrics, this is the name, and the monitoring, right? So we talk already. So here we are providing this information. Then we have a deployment information. So it's a Kube-State-Metrics, okay, because it fetch the detail from over here. So we don't want it to, but it feel free. We have several objects, right, types, whatever you want, you could use it. Yeah, okay. So deployment, Kube-State-Metrics, namespace is this one. I'm fine with the replicas one. In production, one is not recommended, so don't stick with the one, okay. And then selector is this one is selector. Then we have template, metadata, spec, service account, right? This service account we are using, this deployment we use this service account. Then we have containers, and in this this is the name image, name of the image and the port. Okay, again we got something name, we'll see that later. Then we have service, then Kube-State-Metrics, this is the name of the service, right? Again the name is HTTP, port, target port, HTTP, right, selector. So yeah, this, yeah, the things which I need to explain I have explained you. And rest, let's deploy this next. No, I did not make any changes over here. kubectl apply f1 Kube-State-Metrics deployment. Shoot, so it has created 1 2 3 4 5 objects: service account, cluster role binding, deployment, and the service itself, right? So let's go ahead and see kubectl get all level app. What was Kube-State-Metrics? I believe Kube-State-Metrics. Okay, sorry. Monitoring. Okay, so port we have. All right, so we want to see everything, and it did work as we expected. But anyways, okay, sorry, this is not a correct screen for us to see the output from all, right? So here we go. In monitoring, we have this one. This is our pod, Kube-State-Metrics, right? This is the service, and 8080 is the service port. Yeah, you could see we did not expose it to the node port. Okay, and we have daemon set and so on and so forth. And we know once we change, right, or once we want Kubernetes to scrap the target, so we have to update the target. And if I come back over here, if I reload, so I could not see the right Kube-State-Metrics. So what I need to do, yes, so for that I already have this pre-compiled configuration file of the Prometheus. So it's the same file. Okay, let me walk you through again. Version v1 config map metadata Prometheus config, same Prometheus config. Okay, monitoring data, right? The global interval scrap, this one, right? Previously we have added node exporter. Okay, I missed to explain you this one. I'll explain you. Okay, so now I will explain you, because we are going to deploy this one. Okay, so this is our node exporter, and here the Kube-State-Metrics. Okay, this is the job name, and same thing we are doing, right? The same level, whatever we used before, right? Namespace and the service name. So that's the same we are doing over here. Service name, okay, Kube-State-Metrics, this is the service name, the namespace is monitoring. Okay, and here there is a thing. Okay, so we have, right, fine. So action keep and regex is HTTP. Okay, so why is this? Let's deploy first, and I'll explain you then. Okay, and before I deploy, I want to show you something, right, about the node exporter. So you could see here I cannot see the name of the nodes. when you have multiple nodes, so you want to see, okay, which node exporter you could see. So that's why this was the level. Okay, where it has gone here, instance. So what we are doing, meta data Kubernetes pod underscore node underscore name. Okay, and we are saying action replace. We don't want to keep that, we want to keep it as a instance. Okay, so this one, this IP is replaced with the instance name. So let's deploy it first and understand that. kubectl line dash f, and second Prometheus dot Prometheus config. Okay, and now we know after deployment we have to restart the pod. So one very notorious way I already showed you, right? You could delete it, but there is another way we learn, which is very sophisticated and which is recommended. Okay, kubectl rollout restart the deployment is Prometheus okay, so yes, because it doesn't have context in namespace. So Prometheus, right? Then monitoring, and this is auto completion, right? We install kubectl utility. So yeah, okay, we restart it. Then let's check a pod. Cook kubectl get pod namespace monitoring label app equals to Prometheus. Okay, 18 seconds ago this pod has restarted. Okay, let me clear the screen and go back over here and refresh it. All right, so here you could see two changes. Right before the instance, here it was showing some 10 dot or that one and the IP, right? And now it's showing the name of the instance or node. So kubectl get node. So you could see the DSOC3 is the name of the node, and though it's a single node cluster, that's why we have only one over here, right? In day 7 we have spin up multi-node, I think five or four, I don't remember exactly. So multi-node cluster, right? So watch that, or spin the cluster with the multiple nodes if your system supports, and check it over here. So now everything is up and running. Now we want to see our objects. Okay, and as I said, our application Kubernetes application development team, they want to monitor the objects. So for that we have very nice dashboard. 1751519. Okay, so it is, rename it. Okay, it is not in that language, but it's okay. Prometheus, and then import. All right, it by default it says like this. So let's change the time, and here you could see very nice information, number of deployments. If you want, I can zoom a little bit more just to walk you. Cluster pod requested 10%, CPU, right? Cluster memory requested 8.70%, cluster memory capacity allocated, okay, requested limited, everything. When you click on this, you can see, okay, limit requested, and yeah. So why this? Maybe we did not, I mean, of course it's not Kubernetes, our focus is not Kubernetes, we are deploying monitoring, but in real production system where you assign requested, limited, and all these things, okay. And this is one of the crucial thing where teams really fight against. We need more resources, okay, and admin team says no, we don't have enough resources. So by which you can quickly check, okay, sure, okay, we could see over here what are the capacity, why you are not allocating us like that. So might be as a Kubernetes admin you're not gonna share this one. Kidding. So pod capacity, okay, node is 1 and nodes unavailable 0. Okay, you could also see this node. And amazing deployment code DNS, here you have like this Grafana, Prometheus, whatever you want to see. Okay, then stateful, so we don't have any stateful set, that's why we can't see it. We have a daemon set, right? And we could see the pods if you want to see about the pods, but yes, we do not have any data. And containers, we have running container details, but we do not have something else, right? Evicted and all these things. Okay, then of course we do not have any horizontal pod scaling, and also we do not have any jobs, but we have one persistent volume claim, that's why it's showing 1. And kubectl get pvc, oh sorry, not in this namespace, the namespace is monitoring. Okay, that's the main funda we talking T7, right? Part 2. So we have one, only one. Okay, and if I do something like this, so let's see, so still we have one pvc. Dash a means from all the namespaces, and that's why it's showing us a 1. Okay, and pvc is not bound, not available. If any pvc is not bound, you could quickly check it over here. Okay, so we will visit it again, and in sometimes we will be able to see more information. Okay, so this is about Kube-State-Metrics, but you could see from the container things, we do not have much information based on the, or for the containers. Okay, so for that, yes, exactly, we need something. Okay, and we know, because in day 5 when we deploy the monitoring setup in Docker, okay, and of course day 4 also, so we know the C advisor, right? C advisor, it's a tool, okay, which help us to give more information about the containers. Okay, as an admin, you won't know, okay, what or which container is consuming more resources, and accordingly you can inform the team, okay guys, this is the thing. Okay, this container is unnecessary occupying, check what happened, why happened, all those. So for that, I will go to directory number 5, and there we have all the C advisor deployment related ML files. Let's see them one by one. All right, so let's see first file, the deployment file. So again, here the same thing, daemon set. Okay, and now we know why do we need daemon set, right? Because it works in a parallel of kubelet. So when kubelet is a will be on each and every node of the cluster. Okay, and when we have daemon set, then it will deploy or maintain, or it will be running, the pod of the C advisor will be running on each and every node in the cluster, and that will be made sure by the Kubernetes itself, right? So that's why we are using the daemon set. Then we have a name C advisor, C monitoring lab namespace, then the again mesh label selectors, then we have template. Here we also have label same, then we have a container, and we are using GCR, right? Google Container Registry. Okay, C advisor, of course this tool is from the Google itself, it's open source and one of the best tool to get insight about the containers. Okay, and the ports, so in this we have container port is 8080, we have given a name is to HTTP. We'll come on this, hold your thought on that, why I have given a name to a port. Okay, and then some of the volume, right? So everything is the same, right? Whatever we have discussed in, I mean, when we deployed the C advisor in Docker container, right? So we mounted some of the file system. Similarly, we are also doing root fs, var run, sys, docker, right? Var lib docker, read only true. We are mounting as a read only. Okay, and this is the way of Kubernetes to deploy the or containerize the application. Okay, but in terms of pod, okay, we don't do it in a naked containers. And of course the volume, so we have, these are the mounting. Okay, here we are mounting these volumes, and these are our volumes. So root fs, var run, and this name must be matched with the name which we are mounting inside this. Okay, and so on and so forth. And here we have a service, right? And important thing is the selector, it must match with the our deployment or daemon set, that object. Okay, and here we also have the same thing, port 80, target port, and the name HTTP. All right, so this is our deployment. There is nothing special over here. It's just a Kubernetes concept I explain you, and you know what I was gonna say. So kubectl apply -f and then one. Okay, so daemon set created, service account created, and let's go ahead and see kubectl get let's run it here. Kubectl get all from monitoring. So guys, now we have a two daemon set over here, right? And here we have a service, and you could see we do not expose it because it's not necessary, right? And then we have a pod of this, and we know, right, after deployment of this one, we have to configure the Kubernetes, I mean Prometheus, not Kubernetes, Prometheus YAML file. So file number 2 in the directory of 5C advisor. Okay, let's click it means let's open this. Same, right, version v1, and at the end you will be, I mean this file you will be by heart to you will be okay, let me write the file. So kind config metadata, again the data, and global interval config Prometheus. And yes, this is we done for the node exporter. This is for Kube-State-Metrics, and here we have a C advisor, and C advisor is the same service name. Okay, we want to I mean here what we are doing over here, we are saying okay endpoints, and the service name is this one, and in this namespace, so C advisor is the service name, this is the namespace, and of course here we have said endpoint port name and action key and HTTP. Okay, let's see this. Save it. CTL apply -f and q -prometheus config. And now we have to restart deployment. So I just search Control R. Okay, restart that pods. Okay, so 4 seconds ago. Okay, so pod has restarted. Let's go ahead and let's see over here. C advisor. All right, fine. What's the status? Unknown. Okay, so all good. So our C advisor is fine. Here is a job C advisor, and here we go. Okay, all the what kind of basic metrics we already discussed. Okay, in before, right? You could also go in a GitHub repository and find some of the metrics which you mention over here if you want to play around. Okay, but we already saw that in I mean we are now very thorough, I believe. So now what we have to do, so far, okay, in this we are able to see Prometheus, we are able to see the node level metrics, we are able to understand about the objects. Okay, now objects are created, objects are right, so ultimately pod. So now we want more granular insight about our cluster. So for that we have deployed the C advisor, and for C advisor what we need to do, yes, we have to import a dashboard here. So C advisor, definitely it is gonna give us information about the pods, right, the containers, and containers are wrapped around the pods. So we have 11670. I do not remember it. I have just put this on my this notepad, all these numbers, so I'm just reading it and pretending like I know. Okay, anyways, but yeah, I really put a time into this, right, efforts to find and test which one is working best. Okay, so feel free, I already shown you how you could find the dashboard, right? So if you want, go ahead and do that. For me it's fine. And now we have more pod overview. So cluster CPU uses, of course cluster memory uses, pod CPU uses, okay, and service memory uses. It will take some time, we do not have any data at the moment. Then here if you see pod network IOs, right, and here this one if you see Okay, so there's so much information we could not see. Let's see. Okay, yeah, like this. Okay, so all processes CPU uses and nodes, yeah, uses memory, data source Prometheus. Okay, all right, maybe let's little bit play around. 6 hours. Okay, so 6 hours data is not available, so it is not able to show us, but we will revisit this boards which we have imported again. Okay, so now we have a pods level information, right, and which is provided by the C advisor. Okay, and if you want, so I could simply say, okay, kubectl delete -f. Okay, so daemon set and service both are deleted. Let me restart the deployment. Okay, and if you over here, right, of course it is not able to find, right, and we refresh this, you could see all data has gone. So just to prove you, right, we have many information, right, let's see, 30 minutes, 20 per hours, so we do not have any data. Okay, so all this data was provided by the I mean most of, okay, not this one. If you see, like, okay, here you can see these are the node related. Okay, all right, so let me deploy it again. Not config, because we did not delete the config. kubectl apply -f C advisor deployment, and is the deployment fine, and yeah, we will be able to see as soon as it will be here green in Prometheus, right? So it is green. C advisor, let's go ahead and refresh. So yeah, of course it takes some time, 15 minutes. We'll visit it again. Okay, I'll keep on doing. Yeah, we got it. Yeah, we are able to see the information of the pod. So guys, it's completely depend, right, on how big is the organization, right, how many teams are involved in this. Some are meant only interested in pod. Okay, and maybe you, if you want, you can create custom dashboard for a particular pod as well, right? And on that you could provide like this container memory users. If I select E, so you could see all the queries are mentioned over here. So just play around, copy paste this, okay, and put in your favorite AI. Say, okay, this is the query I want to monitor my particular this instance, and you will get the exact query. Put it over here, run the query, you will be able to see. Okay, that's why we didn't spend much time on the Grafana, because when I started these things, the special, I mean, yeah, importing dashboard was there, but now we have so many amazing dashboards. Okay, so just go play around it, and accordingly, if you want, you can also, for example, like we, right, and after that, if you want, you can delete it or do whatever you want to do. Okay, so for example, if I click over here, right, or maybe let's see, where is this one? Okay, so let's, I know the shortcut over here. So yeah, there is an option, you could edit the back here. Yeah, here we exit edit discard. Okay, so here is the option edit. If you go over here, you can edit and play around it. So when you select this one and press E, then directly you come on the edit mode, right? When you select this one, for example, this one or this one, when you select V, you could see like something like this. If you want to zoom, press escape and come out. Okay, so guys, so far let's quickly check what we have done. Okay, we started with setting up a cluster, right? Then we deployed Prometheus as a deployment. right? Then we deploy Grafana as a deployment. After that, we are interested in to see whether our cluster, right, is healthy or not. So we deploy node exporter. Okay, once we done that, then admin team is happy, Kubernetes admin team, DevOps are also happy. Then Kubernetes application developers, right, they have come, they say, wow, you have the things, why don't we want to see, why don't we are not able to see anything, do you have something? So as an admin, as a DevOps, you said yes, and we deployed Kube-State-Metrics for the objects, and they are happy too. And they said we want more information, let's say the manager. Okay, said, okay, I want to know exact best what is happening based on the containers, right? We said yes, we are DevOps, right? And then we deployed cAdvisor, and finally we have this entire stack like this. Okay, now if you see over here, what do we don't have? Basically we have everything, right? But for each and everything we have to do manual configuration, and that's, I mean, that is of course one of the use case. So for, as I said, if you are only interested, right, in Kube-State-Metrics, you are not interested at all in everything, right? So it completely depends on what you want to do. Okay, so I have explained everything, right, which supposed to be or which should be or which should, you know, right, if you are beginning or if you are setting up this monitoring first time. And I believe this is the way we learn. When you start setting up the things, then we realize, okay, I need this thing, that thing. It's very simple, right? So it happened in our daily life as well. So when new requirements come up, okay, accordingly you prepare and set up. Okay, but I have showed you all these things. Another thing I wanted to show you, in case of course, if, yes, when you are monitoring or if when you are having multiple clusters, then what, right? You have one of the cluster where only Prometheus Grafana is deployed, for example, very big company, right? Or maybe you have a product SaaS based, so, and in your setup is in Kubernetes. So what would you do for each and every client? Maybe you are maintaining a cluster, not even a namespace, so you have to monitor, right? So there you could, and in that case, when you are set, you have multiple clusters. I mean, of course there are more ways, I'm just giving you example. So you may have Prometheus deployed, and then you can configure like this. Okay, Kubernetes cluster client 1, Kubernetes cluster client 2, and so on and so forth, or however you like, right? So this is about this thing. Okay, so what I have done now, we want to see the service discovery. Okay, let me clear the screen. And service discovery, we know, we already talked in part 5 when we set up monitoring for Docker. Okay, but there service discovery and here the service discovery is completely different. Okay, so let me show you what I mean. So, okay, Linux, yeah, we learned this commands, right, in Linux day 1. So we are in service discovery, here the screen directory. Let's see what is our first file. So in service discovery, we are not gonna make any changes, right? So make any changes means these are the deployment, right, or the workload or pods or whatever we want to say, simply all together as a workload. So instead of that, what we are going to do now, in this configuration file, I'm going to make changes in configuration file. So what I will be doing, so you know, since beginning we are using this Kubernetes SD service discovery config and role endpoints, right? So here, instead of doing the configuration for each and every files, what we are doing it right now, so we are just saying, okay, metadata Kubernetes endpoint port name, and we want to keep, and we want to say, okay, metrics, regex, https, and http, or whichever port name is like this. Okay, so whether port name is metrics, whether port name is https, whether port name is http. And that's why, if you remember, right, I was explaining several times, it's a deployment, right? So we had this option, the port and the name. So that's why we are putting that name. Okay, so it's there. So we are just adding this block and removing rest. So I also rename the configuration as well. Okay, either I could put this as well. Okay, if you want to continue with the previously YAML file, okay, to see how it looks like here, right, instead of all this thing. So just in the same file, copy from this much, okay, and put it in that file and deploy it and restart. So that's, I'm going to do the same. kubectl apply -f Prometheus config YAML. Let's apply it and then restart. So kubectl rollout restart deployment Prometheus and get ports. It's smart enough, it's 6 seconds ago. And if we go over here, so now see, instead of manual configuration of multiple times or doing from each and everything inside the cluster, we are doing like this. But what just happened? Okay, some okay, zoom a little bit. So this instance matrix 9153. Okay, and this one, right? What was the, let's copy this. I wanted to show you from where you can check it, right? When I copy, so you simply see, and this will match with many places. Okay, it matches here. If I explore this one, so you could see two. So these are the predefined, right? Or I would say the discovered labels, right? These are the discovered. It has HTTP, okay, and it has metrics. Okay, if you see metrics, port name, HTTP port name. Then if I go more here, let's explore this as well, or we could do one thing. Yes, exactly, service discovery. And here you could see HTTP, HTTP metrics, HTTPS metrics, HTTP, DNS TCP, okay, and DNS HTTP. So these are the port name which are already discovered. So we can use, right, this name, okay, and by which we can monitor the targets, right? Well, Prometheus can scrap. So in this case, what happened? If you see, where is our Prometheus? Yeah, so 9090. So we do not have over here, right? We do not have Prometheus. So Prometheus, we are not monitoring Prometheus itself. So let's first do one thing. I'll go over here and let me show you. So this port name, right, we just saw. So based on that, this regex, right, it works. Matrix, HTTPS. If you remove this, then it is going to scrap everything. Okay, so we are not going into that, but I wanted to show you how does it work. Okay, so let's open a service file, and we can see 9090 is not here. Why it is not here? So let's go to the service. I mean, of course, it's a service file. And here, if you see, okay, so this file, and let me show you one more file. I believe remove, it will be okay. Let's try to open it over here. If not, then we'll open it there. What do we have? Config deployment service. Okay, so file number 3. Clear the screen. Let's open. And if you see, previously here I did not put the name of the port. Okay, that's why I was pointing out since beginning. Okay, somewhere the ports names are matrix, HTTP, okay, these, and when in day 7 when we talk about this ports, right, then I told you the naming, giving a name, it's really important, and it has a significance in monitoring. So that's how you monitor. Okay, and that's why it is given a name HTTP. And now what I'm going to do, quit, and we are here, and then this is the file, okay, in service discovery directory, and we are going to apply it, and then we will be able to see Prometheus in our auto discovery configuration. So these are just what's the file name to where we have deployed. Then let's restart the container, and not container, I'm sorry, pod. Okay, and that pod. So 8 seconds ago. Okay, so now when we refresh and see, we will be able to see the 9090 9090, and here we go, it's right here. And if you notice, okay, here 3000 port is also not there, okay, which is for the Grafana. So I just showed you just to know, okay, how this works, service discovery works. Okay, and now you know you have lots of labels. Okay, you could also have on labels as well, okay, customized. But for monitoring, you could see there are so many levels out there. So use it, play around it, okay, and learn how to use if you need. Otherwise, I think I already explained you how you can use it. Okay, but if you want to learn more, go ahead and do that. But still, if you see, we have 8443, and what is this here? TCP port. We want port underscore name HTTPS, right? And this is not working correctly. It is down. So what is listening on HTTPS, and where it is? True. Kubernetes. Yes, here we go. Namespace, right? Which is in default. And so let's see, and we know based on our configuration, we are we are monitoring services, right? So let's check what service we have. kubectl get svc. So okay, it's a Kubernetes service. Okay, let's dig more into. Okay, so output is a YAML. Okay, what is the kind service? Of course, component. Okay, label API server, provider Kubernetes. Okay, so this is for the API server, right? So here one thing is, if you see the name, right, HTTPS and the port 443. So here there is a challenge. Okay, and what is challenge? Okay, let's continue, then I'll show you that thing later on. So it is the name of the port is HTTPS, right? And in Prometheus, for there is a challenge, okay, for when, because it's an API server, and API server needs authentication, and the challenge is this API server requires scheme, okay, bearer token file, the token, and the TLS config. Okay, so there are some other workaround as well if you want to. Okay, you could do this, but I would recommend you to go ahead with the HTTP and HTTPS. So whatever we have seen so far, so let's what is Prometheus company, right? So this is the, because we know Prometheus listens on HTTP endpoints, right? So all the metrics were exposed, but API server is different, and we know API server, of course, it's the entry gate, and we always lock on the entry gate, right? So that's why we cannot, or Prometheus cannot directly go ahead and grab it. So what we can do over here, let me copy one config file as a one, and we make some changes over here to fix the issue. I'm showing you live the troubleshooting. Okay, so I've just copied it for Prometheus. So HTTP is the problem, right? So it says endpoints, So HTTP, it's fine, but for HTTPS, no. So we could simply do one thing, remove like this. Okay, and one more thing. Yeah, if you see, where is this? 951. I think this one is DNS. Yeah. Okay. So port underscore name. Okay. Metrics. We see the DNS protocol. The HTTPS 080909184. Oh, okay. 8443. This one. Kind port. Okay. I'll come on that later. I wanted to show you the DNS as well, how you can monitor and why you should monitor. So let's fix this first. And so we have removed it, right? And only I have removed the HTTPS, and metrics and HTTP is fine. Now let's apply Kube-State. Apply -f for, okay, and then restart. Okay, and to check. Oh, sorry, not this one. Okay, so 10 seconds ago. So restart, and now we are get rid of. Let's refresh it. Okay, everything is up. All right, and what it's showing, what's the status over here? Okay, so it's 5 minutes. Okay, all good. Okay, so our jobs, right? This one 53 DNS 8080 everything is up there, and we can check here confirming Prometheus, right? Not at all. 30 minutes, 5 minutes, and we have some information over here, right? We do not have any error, and yeah, so on and so forth, right? Similarly, we can go node exporter, we can see that information. Kube-State-Metrics, 24 hours. Yeah. Okay, so that is also fine. And pod overview. Okay, so everything seem working. Okay, so now what? In case, okay, if you want to monitor, because that I mean API server, right? Of course, we also interested in overall the components, right? Control plane, which is called, right, in that as well. So for that, what we have to do, we have to do something different. And before that, I would like to show one thing over here in this. Let's go ahead and do one thing. Yeah, because here we have a DNS, right? So we should be able to see some DNS if you are interested. And from my experience, yes, we should watch the DNS, right? And why should we? So let me first import this, then I'll tell you why. All right. Okay, very good. So see, DNS is everything, because all the, like with this configuration, right? If I go in data source, right over here, if you see, so how this is resolved because of the DNS. Okay, so that's why this is a critical, not only important. If you see core DNS, right, so it's a critical component of your cluster. But if you don't wish to monitor, you wish, okay, so I could just recommend, based on my experience, I found, okay, it provides a lots of information. Just don't hang or stuck with this memory and CPU uses. Okay, I mean, of course those are also critical, but go ahead and learn about more what it's saying. Okay, and this is about core DNS. Okay, so before I show you how to monitor your API server, I wanted to tell you one more thing. And for that, let's import cluster. Okay, let me refer my notes. Yeah, okay. So 15761. Okay, this is the another, and you maybe notice I'm always copying the ID and put it like this. Okay, because when after once you save, then it's, yeah. Okay, so simple. What you can do, like if you come on dashboard, so you quickly just refer, right, the name of the dashboard. And when you are creating custom dashboard, so naming convention based on the what I did. So like if I'm sharing a dashboard with any one of the team, so I give a name of the team or department or whatever use case, or whatever you like. Okay, but give some meaningful. So here is the API server. Okay, so I have imported so far this many. We will import more. Wait. Okay, so API server, if you see, we do not have any of the data, right? API, and you know why API? So API is also critical because we know everything, all the requests, everybody is interacting with the when to the cluster via API, right? So that's why API monitoring, or especially being an admin, you would love to monitor API server, kubedns, okay, and node exporter, what is happening with the nodes, all this thing. So let's fix this and see the data over here. So this is the service discovery, and go ahead with the third one, Prometheus config. Okay, again the same configuration file, nothing new. Our job name is same, endpoint is same. Okay, endpoint port name is the same, and that is what we have changed. A matrix and the HTTP, right? If you want, you could add DNS over here, and it is, but it's already scrapped, right? We could see it's scrapping, right? 9153. Okay, and so as our this one, okay, API server has some special requirement, and what is that? So I have just given it a name like this. You're free, whatever you like. Okay, Kube API server, or let's say maybe just for better readability, Kube A E, sorry, R, and I'm just not with the O, place API server. Okay, so till here all good. And here, if you see regex, okay, so here what we are doing, so same service name Kubernetes, right? And how did we check it? kubectl get cc, here Kubernetes, right? And namespace is default, but here what we are doing, here we says Kubernetes endpoint port name, that is also okay. Action is keep, and here regex is HTTPS. Okay, and scheme is, now we introduce a scheme HTTPS. Okay, I will also summarize this. Hold on. So we have to provide three things, right? What three things? Scheme is HTTPS over here, right? And then bearer token files. Okay, this is over here, and TLS config, like this. Okay, so we just add this some of the lines. Okay, so if you are following along with the same, so you just copy and update your existing configuration file, or config map file, not configuration. Of course it would update, but it's a config map, right? So let's apply this. Clear the screen, apply -f, and the third one. Okay, configured. Then yes, we know the drill. Restart, get parts. Okay, running 4 seconds ago. Let's go ahead, refresh. All right, but it's our still, it's not, these are not green. I want it should be look green. Okay, do it. Okay, so all green, up, up, up. Here 5 targets. Right here we have 1 target. And now if we go over here and refresh this guy, right, 1 hour 5 minutes. Okay, it may take a little bit more. Apply connect. Okay, we do not have information. Okay, let's give it some time. Okay, and meanwhile I wanted to show you one thing over here, and that thing is this one. Okay, so like scheme, right, HTTPS. So either you could do one thing, you could, I mean, if you don't want to have a separate, okay, configuration, so you could create one scheme, okay, like endpoint and here itself, right, before putting anything over here. So like for example, yeah, after this, right, you could put a scheme HTTPS and TLS and all this information, and you could have everything under this scheme, all the ports, all the service discovery, everything that's for only for this HTTPS instead of HTTP. So these are the 2 use cases if you want to. Okay, so go ahead and explore more about it. Okay, so yeah, that's I wanted to tell you, but I'm fine, and but I have given you enough practice related scenario where you could deploy, how you could deploy, and go ahead and do that. Then if you see, we are getting data. Okay, but no data, so I just click on this, I did this. Okay, so it says job. Here if you see, this is the query. So like if you import any of the dashboard, okay, but before that, editing this, I want to import one more. I'll show you how we can fix that, but there are some more amazing dashboards. Okay, 15757. So meanwhile it will take, I mean, it will take some time, and some information will populated or popped up or appear. Okay, so this is one, and what is next one? 10,000. 10,000. Yeah, that's I know by heart. Let's verify if I just remember or not. But no worries, this is also written on my notepad. All right. So we, okay, API server. All right. So if you see here, right, E or edit, and we are talking about this one. So cluster, 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 up, job. So simple. Let's check our Kubernetes API server is like this. Okay, so let me go here. So our job name, like if you match here, job, right, this one, our job name is Kube API server. Okay, so what I will do, I will just change this, right, Kube API server, like this. Let me copy it and remove it. So let's go ahead with this, and then we run the query, and it's green. Okay, and it's I mean, it's saying like this is the IP. We can confirm. Okay, the same up instance, right, and it says up. We are all good. Then not discard, save the dashboard. Okay, fix up, put it, not this one. Okay, just the API server name, pi, not pi, fix API server in name inquiry. Save it, and if I go back to dashboard, okay, and if you see the version v1, it says deprecated Kubernetes resources. Okay, so version v1 is deprecated according to it. Okay, resources endpoint, right, so I have to check the endpoints and fix. So why this is helpful, like you are Kubernetes administrator and or application developer. So from here, instead of checking each and every time, you can simply check it over here whether it's deprecated, or should I plan for the upgrade, or I should upgrade. I mean, there are other ways as well. I'm just giving you a use case or example. Okay, and yeah, that is, we can check it over here. Then API health is up, right? And same, like it says no data. Okay, so go ahead, click on this, click E for edit, and come back, press escape or save it, and fix this. Okay, when you are building your own dashboard. Okay, and if we see over here, okay, so let's zoom it with the V. So get, put, watch, connect, you could see. Okay, request by the verb. So this is the overall incoming traffic, like it's showing us in 5 minutes. Let's say 6 hours. So yeah, of course, it's not possible. Or let's say 15 minutes. No, 5 minutes. Okay, so that's how you can utilize the dashboard. Okay, or if you want, okay, so I mean, this day 8 was completely focused on the Prometheus, how we set up, right? If you want to learn, or if you want me to make a series, okay, on Grafana, let me know. Okay, I'll make one in the comments. Okay, so yep, save dashboard. Okay, we don't, nothing to save. Okay, so this is about API server. Let's come back. The dashboard. Oh, sorry. Okay, all right. Discard. I don't want to anyway keep it. So two more dashboard I would like to show you. So first one is the Kubernetes view global, and if you see, it is very amazing. Okay, view. So global CPU uses. Okay, especially for admin. I mean, of course, if you are not admin, if you are just DevOps, because DevOps also does all these things, right? Not every company has Kubernetes administrator. So we have number of namespaces. Okay, running pods are 12, number of nodes 1, and Kubernetes resources count. So running containers, okay, running pods, the same. Endpoints are 8. Okay, services are 7. Persistent volume 1. Nodes, if you see, I'm referring over here. Nodes are 1. So only one node is in the, and we also check the persistent volume. We have 7 services, right? If I do like this, then we have more information. Okay, so this about cluster CPU utilization, cluster memory utilization. We do not have the by the namespace any information, right? So for Kubernetes, pod, QoS classes, right? Pod status reason, evicted, node affinity, restarted, everything network you will get on this. I like a lot this one. It's very amazing. Okay, the creator of this dashboard is not did not sponsor us. No need to, right? It's created by the community, right? And it's shared to community can get benefited out of it. Another one is this one, right? So here you could also see the cluster memory uses. Okay, and like this memory, pod memory uses. Okay, CPU, network, pod. So you might be thinking, okay, everywhere I have seen the same information. So guys, here the simple reason to bring this up over here, you can, I mean, you realize or you can visualize, okay, this many dashboards are possible. Okay, in custom you can simple copy paste this one. I mean, even you can copy the panel itself, okay, and create your own custom dashboard. So you could have this facility in the Grafana as well. So go ahead and explore it more. And I think from my side, it's more than enough things I've shared with you. Okay, and if I go over here, sorry. So yeah, these are the things I have explained you, right? We deployed Prometheus. So all these are manual way which I showed you to install. And why manual way? because once you understand manually, then there are other ways as well. You can deploy it using the Helm chart, you can deploy it using the operator. Then you think, okay, I do not have time to understand the Helm, so should you first learn the Helm and then deploy it? I mean, although all the instructions are there, right? But you are very good with the only with the Kubernetes. I'm just talking about, let's consider hypothetically, currently, maybe in future, of course you would like to learn Helm operator. And of course, if you want to me to make a series on this, please suggest in the comments. I will definitely make a series or build a series on that. So, but for timing, we have done the Kubernetes, right? Day 7, part 1, part 2. We learn this thing. So, and you may be realizing day 8 entirely. We start with the architecture, understand the fundamentals, and then we can go ahead and talk about how we can install on virtual machine, right? Then we learn how it happened in different installation way, okay? And then we deployed it containerized way. We connect whether container is running somewhere else, right? Then today we learn how we can do the Kubernetes. So that's the thing I explain you, and I did this manually. And I believe if you want to explore with the Helm or Node, go over there, the official repository, find it. Now I believe it will be very easy for you to understand what is happening. Okay. And then, so this is the Prometheus deployment. Then here in Node Exporter, we deploy Node Exporter, we change the configuration, then we run a problem of the access, then we executed this file, right? And we learn about this. Then in fourth one, State-Metrics, right? We deployed, and we also do the update the config map accordingly. And similarly for the fifth as well, we deployed CAdvisor and we changed the configuration. And similarly for service discovery, okay, which I believe you would like to do in your production environment instead of, and yeah, if I were you, I would prefer a service discovery way, but this is not the always use case. That's why we learn both the ways, right? Here we can have something like this. Okay, go with the cluster service discovery, or if you want to API, if you also want to um, monitor your DNS server, okay, so find it. Okay, I think there is some, I will put one configuration out of this repository somewhere over here, okay, because I remember somewhere I tested it. Okay, so that will be also kind of same if you want to separately, but I believe it's already there, but sometimes it is there, right? So separately it means maybe your Prometheus is running on one of the server, okay, and you want to monitor API server of the another cluster, right? So maybe multiple cluster kind of thing is there, so you can configure in your configuration file, okay, and based on that you can check it. So we have learned everything, more than enough. So this was not just a beginner tutorial, right? But we successfully done it. It's a day it is completed. And if you want to refresh, so this is the our playlist, okay, and here I was referring about this one, okay, day 7 part 1, and if you see day 7 part 2 Kubernetes, okay, which is approximately 7 hours 33 minutes, and where we discuss each and everything. So if you go over here, okay, and maybe if
I
you would
welcome you.
like, so you could go over here. Where is this one? Okay, more, okay. So if you go here, okay, so these are the timestamp, okay, here everything: cluster setup configuration, pod and container management, replica set scaling, deployment rolling update, daemon set, successful set, persistent volume, okay, config map. So there are different config maps as well, how you can use it, secure sensitive data, how you could secure networking and service discovery, Also, we here we talk about services. Okay, and we also we have also done a project over here. So go ahead and use this resource, okay, if you want to, and if you don't want to, it's you wish. Okay, so I just wanted to show you where you can find what. So this, I believe this would be very helpful to you if you don't know anything. Okay, and if you know everything, then sorry for wasting your time. Okay, let's get back to the presentation. All right, it's time to move on for the next topic and conclusion and what next. So before we conclude, if you have any questions or thoughts, drop them in the comments. If this tutorial helped you and you want to appreciate our efforts to bring this tutorial to you, please leave a thumbs up to this. And in this session or today, what we have covered, so we started to setting up a Kubernetes, then we add a Prometheus and Grafana, then we deploy node exporter, then Kube-State-Metrics, then C-Advisor to watch application level metrics as well as the container level metrics. Then we also learn how we can do the monitoring as a automated monitoring using the Prometheus. So we do not have to configure anything at all. Once configured, and that is for forever. And we also learn the several use cases about the control plane, how to monitor, what not to monitor. That's very, very important, right? Because there are already, I believe now you realize there are n number of metrics, right? So which one to monitor and which one not to monitor. So that's what we learn. And of course, troubleshooting and the dashboards. So that everything we have learned today. This is end of the day 8. And if we see our roadmap, right, so we have very successfully completed day 1 to day 8, and in day 8 we have throughout learned each everything you need to know about setting up a Prometheus and the Grafana. We start with the basic essential things, right? Then we understand the architecture, we install on the Linux and the bare metal machines, and then we containerized it. We also learned the several use cases when it is not deployed as a container or you want to monitor particular container, then how you do this. And today we have done with part 5 and part 6 with the setting up Kubernetes based monitoring, right? So that's what we learn. And additionally, if you have or if you want to contact us directly, this is our email ID. And once again, thanks a lot for your kind support and love. Thank you very much for that. Then see you next week. Until then, bye bye.